Hi everyone. In today's video, we are going to discuss how to wind a solenoid coil. Objective: at the end of this video, you will be able to 1. Wind a solenoid coil. 2. Determine the magnetic effect of electric current. Let us discuss the solenoid coil. A solenoid is a type of electromagnet formed by a helical coil of wire that generates a controlled magnetic field. The coil can produce a uniform magnetic field when an electric current is passed through it. All wires produce a weak magnetic field when electricity passes through them. To enhance this property and create a strong magnetic field, wires for a solenoid coil are wound into a coil. The amount of magnetic field induced in the coil depends on the number of turns and the amount of current that flows in the coil. A solenoid coil is a common electrical component that uses a wire that is tightly wrapped around a core, usually made of metal, to generate an electromagnetic field. Solenoid coils are a very versatile tool that can be found in production machines, appliances, and various forms of automated equipment. The basic purpose of a solenoid coil is to convert electrical energy into mechanical energy to supply linear motion. Copper wire is the most common type of wire that is used to construct a solenoid coil. There are other types of wires available, but none of them have the same conductivity and pliability as copper.
Here's a simple explanation of how a solenoid coil works. Wire coil. A solenoid coil is usually made of a long, thin wire that is wound into multiple loops or turns. The more turns the coil has, the stronger the magnetic field it can generate. Electric current. When an electric current flows through the wire coil, electrons within the wire start moving in response to the voltage applied across the coil. This movement of electrons creates a magnetic field around the coil aligned with the axis of the coil. Magnetic field. The magnetic field created by the electric current circulating through the coil is similar to the field generated by a magnet. The field lines emerge from one end of the coil and loop around to re-enter the coil at the other end. Attracting objects. The magnetic field generated by the solenoid coil can attract objects made of magnetic materials such as iron or steel. This attraction occurs because the magnetic field lines from the coil interact with the magnetic domains within these materials, causing them to align and create an overall attractive force. Applications. Solenoid coils find use in various applications. For instance, in an electromagnet, a solenoid coil wrapped around a core made of a magnetic material can create a strong magnetic field when current flows through it. This electromagnet can be used in cranes, door locks, MRI machines, and more. Solenoid coils can also be used in valves and relays to control the flow of fluids or electricity based on the magnetic forces they generate.
Step 1. Arrange the tools and materials as listed below. 1. Super enameled copper wire with 22 SWG. 2. Circular type plastic bobbin. 3. Hand drilling machine. 4. 3 mm drill bit. 5. Permanent magnet pieces. 6. Batteries 12 volts. 7. Knife. 8. Multimeter. Step 2. Make 2 holes for 3 mm at the side of the bobbins. Step 3. Start to wrap the bobbin with the enameled copper wire. Step 4. Wrap the coil evenly all over the bobbins. Step 5. At 200 turns, take tapping by folding the wire and inserting it in the first drilled hole. Step 6. At 400, turn again and take a tap at the second hole. Step 7. After 600 turns, stop wrapping and cut the wire. Step 8. Remove the insulation for an inch at the ends of the wires and add the tapping. Step 9. Take the multimeter and set it in continuity mode, then test the coil by placing the probes at the ends of the coil. Let us discuss the effect of electric current in a solenoid. Spread out the particles that have magnetic properties like pins, iron pieces, and small magnetic pieces around the solenoid coil. Connect the positive and negative terminals of the 12-volt battery to the first 2 terminals of the solenoid coil and make 200 turns. Observe the movement of the particles attracted by the coil. Now, connect the battery terminals to the coils for 400 turns and observe the particles being attracted more strongly by the coil due to the stronger magnetic field. Now connect the battery terminals to the coils for 600 turns and observe the particles being attracted by the coil more than 200 turns. So a greater number of turns will generate a stronger magnetic field. You can also use a variable DC power supply instead of a battery to control the magnetic field by controlling the current flow in the solenoid. I hope after watching this video you can wind a solenoid and check the magnetic force developed in the coil. Thank you for your time. Have a good day.